All right, friends. So we got a couple scientific-y things here. This is called a dynamic cart. I have a meter stick. I'm using the centimeters side. I have a very, very light string attached to a hanging mast down there, as you can see, and going over a pulley. And what I'm going to be, I've also got a clock running. Um, the ultimate goal here, this is the problem at hand. I want to find the mass of this. Okay, and in order to find the mass of this, what I'm going to do is I'm going to pull this back. From here until the mass hits the ground is 20 centimeters. So I can see that here. So what I can do is I can release this. And there are a couple things that I'm able to measure during that time. Okay. Number one, because I know the mass of that hanging mass down there, I know the force that is pulling this. Okay, so I know what the force in this string is. I also know how long it took because I had this clock running. If I were to video camera this and look at it, I could look at how long it took from the time that I released it for it to go 20 centimeters. And I could use that to find the speed, for example, of the cart here. So I know how much force there is. I know how long that force was pulling. I know the change in speed. And there are actually two ways to do this. But if we have to find the mass of this, the two ways that we can do this are first with Newton's second law, and second with our impulse formula. And what I'm asking you to do is to engage in a conversation with me about how to do both of those so that we can kind of figure out which one of those would be the most successful way for us to find the mass of something that we don't know. I should mention that because of a couple issues here, this is fairly approximate, but it would give us a pretty decent idea.